All right, guys, here we go with chapter 6. Moving right along. Section 6.1. I think a lot of this is going to feel kind of familiar to you. We're going to describe something called random variables. And then the random variables are going to turn into the basis for this big idea of the second semester, the inference stuff. So as we progress from the rules of probability, which was the last chapter, two-way tables and Venn diagrams and tree diagrams, and as we move away from just studying probability for the sake of probability towards formal statistical inference, which is the whole point of the second half of this book, we start by concentrating on random variables and the rules that go with them that are based off of probability. Okay, flip a coin 3 times. We're going to list the sample space of heads and tails. Okay, so I'm going to do a little brackety thing. It could go heads, heads, heads. We could have 2 heads and 1 tail, and it could go in 3 different places. So we'll do this. It'll go heads, heads, tails here, heads, tails in the middle there, or tails, heads, heads. We could get 1 head and 2 tails. So we could get the head to come up first and then 2 tails, or we could have the heads come up second, or we could have the heads come up third, which is not how you write that. Okay, or you could get tails to happen 3 times. There are 2 flips times 2 options for the second flip times 2 options for the third flip. 8. 1, 2, 3, 4, 5, 6, 7, 8 possibilities there. I would like you guys to put in your notes that this is not a random variable. I will tell you what a random variable is, I promise, but that's not it. List the sample space for the number of heads that come up. Now it's a numerical thing, not a list of a bunch of possible things. So I do a bracket. It's possible the heads doesn't come up at all. It's possible that heads comes up once or twice or 3 times. I would like you to point out that this is a random variable. Okay, it's got to be numerical. That's the thing. A random variable has to be a numerical outcome of a chance advice. At number 2 above, if we let x be the variable that represents the number of heads, then x is in fact a random variable, which I just pointed out. So why I just wrote it twice, I'm not really sure. But hey, we're just trying to get through this. It's 2021 now, I guess, but we're still just trying to get through it. Anyway, a random variable is a variable whose value is a numerical outcome from a chance process. And generally, I'm not sure why, but generally we use capital letters at the end of the alphabet for this, right? So that's why I picked X with a capital X. As before, when using random variables to represent a random process, that's supposed to be the word represent. I haven't done this in a while. To represent a random process, the sample space S just lists all possible values of the random variable. Definition. The probability distribution, which is something we did actually see in the last chapter, so this is why it'll look similar to you, even though it's been a while. The probability distribution, it just lists the entire sample space and all of the probabilities for each event. So I'm pretty sure on the next page, I haven't looked ahead, but we're gonna list out the sample space. The probability distribution for this this little set of events here. Now the x will be 0, 1, 2, or 3, but as you can tell, heads coming up twice, that's more likely than heads coming up all 3 times. That is more likely than that. So these probabilities are not all 1/4. There are a certain amount of eighths, right? So go to the next page and we'll talk about it.